A mystery barrier was encountered by two space probes when they entered interstellar space, 45 years after they were launched. The probes had traveled far beyond our solar system. The Voyager 1 and 2 spaceships have discovered something unusual outside of our solar system. What is this exactly? What mysteries lay beyond the supposedly impassable barriers? Let's explore the amazing adventures of Voyager 1 and 2. Detected something beyond the edge of our solar system. Voyager is the longest-running mission in the annals of space travel. Amazingly, some 45 years later, NASA is still in continual contact with both probes, which take routine commands and transmit collected data back to Earth's deep space network before starting the even more ambitious Voyager interstellar mission, which aimed to explore the outer reaches of the Sun's sphere of influence and beyond. NASA extended Voyager's mission to include the two outer giants, Neptune and Uranus, after completing all of its initial goals within 4 years. Voyagers 1 and 2 have now separated from Earth by a distance of 22 billion and 18 billion kilometers, respectively, and have entered interstellar space. However, even the long-lived Voyager probes are running out of time. The probes will likely run out of power by 2025 and will be permanently dark. In order to extend the mission for a few more years, NASA has started turning off the instruments on the probes in advance. However, they will leave behind an incredible amount of data when the Voyager probes eventually go dark. Voyagers 1 and 2 were intended to have a 5-year mission, but their forward-thinking team of scientists and engineers made a variety of design decisions that allowed the probes to endure a far longer journey. Each probe has a long-lasting radioisotope thermoelectric generator that turns the heat produced by decaying plutonium-238 isotopes into electricity. The probes also contain 16 hydrazine thrusters, including 8 backups, and redundancy for the majority of their 11 scientific instruments in case of equipment failure. Most significantly, the launch took place at the ideal time. NASA took advantage of the once every 176-year alignment of the planets when the Voyager planetary mission was launched in 1977. This alignment not only allowed for flybys of Neptune and Uranus with little course correction, but also gave the probes a gravity assist from each of the giants they visited, increasing their effective velocity beyond what they could achieve with their own rocket propulsion. At the time, this concept had only recently been tested on NASA's Pioneer missions to Jupiter and Saturn, making it rather innovative. Voyager 1 left the ecliptic, the plane of the Earth's orbit around the Sun, in 1981, moving 35 degrees to the north. Later, Voyager 2 traveled 48 degrees south and passed over the ecliptic. The cameras on both probes were turned off to save power after the Voyager planetary mission was extended to become the Voyager interstellar mission. The final picture captured by Voyager 1 is the well-known shot of Earth as a pale blue dot, which is the furthest picture of Earth ever taken at a distance of almost 6 billion kilometers. However, the voyages of the Voyagers had just begun. The probes would have to pass through the termination shock, where the interstellar wind encounters tremendous resistance from hypersonic solar winds in order to enter interstellar space. After passing through the termination shock, the Voyagers would reach the heliosheath, where slowing solar winds accumulate and become hotter and denser, then the heliopause, which marks the complete separation of the heliosphere from interstellar space. Contrary to popular belief, our solar system does not stop at the beginning of the interstellar medium. In fact, it will take Voyager 1 another 300 years to reach the Oort cloud, a massive nebula of ice planetesimals that encircles our solar system like a bubble, and another 30,000 years for it to leave the cloud and leave our solar system forever. The Voyagers made a remarkable discovery when they passed through the heliosheath. The heliospheric current sheet is a ripple that forms as the Sun's magnetic field spins in opposite directions at its north and south poles, similar to the rings that form when a stone is dropped into water. This sheet, however, compresses as it encounters the termination shock, as if the edge of a pool were being hit by the ripples. The Voyager probes found that these stacked ripples eventually condensed into magnetic bubbles after the termination shock. This indicates that the heliosheath's boundary is not as smooth and distinct as previously believed. It is a shifting, magnetically bubbling environment instead. This perplexing discovery caused a full reworking of our heliosheath model. The Voyager 1 space probe became the first man-made object to leave the Sun's heliosphere and enter interstellar space on July 25, 2012. It was moving at an amazing 540 million kilometers per year, or 3.6 astronomical units, with an astronomical unit equaling the distance between Earth and the Sun, which is around 149.6 million kilometers. It was a revelation that Voyager 1 passed the heliopause at a distance of around 120 astronomical units from the Sun, because it was unclear exactly where the heliopause occurred. Surprisingly, some early models placed it as near Jupiter as possible, while others placed it much further away. Remember, the heliopause is the limit where the Sun's solar wind is stopped by its collision with the interstellar medium, similar to the clash of two powerful bodies of water. The solar breeze is a constant stream of charged particles from the Sun's outer layer, such as electrons, protons, and alpha particles. The interstellar medium, on the other hand, is made up of charged particles, gases, and cosmic dust that were left over from the Big Bang and ancient supernovae. When these charged streams collide, they alter course and produce an equilibrium region known as the heliopause border. NASA was initially unsure whether Voyager 1 had genuinely passed the heliopause and entered interstellar space. The probe's plasma wave detector detected a large rise in plasma density, 80 times that of the outer heliosheath, as expected by models, as well as a spike in galactic cosmic rays. However, something odd did not occur, leaving scientists perplexed. Voyager 1 detected no change in the ambient magnetic field after crossing the heliopause. What was so surprising about that? Voyager 1 and 2 detected something beyond the edge of our solar system, however, presuppose that in a region dominated by the magnetic fields of other stars, the ambient magnetic orientation would shift. Amazingly, Voyager 1 found no detectable change in the surrounding magnetic field. Due to their confusion, NASA took over a year to confirm that Voyager had indeed entered interstellar space. On November 5, 2018, Voyager 2 joined Voyager 1 as the second artificial object to enter interstellar space. Voyager 2 is moving at a somewhat slower speed of 490 million kilometers per year, or 3.3 astronomical units per year. Similar to Voyager 1 6 years earlier, the crossing took place 120 astronomical units from the Sun, yet neither probe noticed any changes to the Earth's magnetic field. But something else caught scientists off guard. The Sun, as you may know, undergoes 11-year solar cycles in which its activity grows and wanes. When Voyager 2 crossed, the solar winds were at their strongest. Models suggested that the heliosphere's size would vary with the solar cycle, therefore. Voyager 2 should have crossed it when it was expanding. Our models were incorrect because Voyager 2 traveled the exact same distance to pass the heliopause as Voyager 1 had done 6 years earlier. This proved the importance of using field data to test theoretical models, just as the magnetometer results showed. We now believe that compared to what earlier models suggested, the boundary between the heliosphere and interstellar medium is far more twisted and chaotic. One popular theory holds that our Sun originated from a hot, highly ionized zone after the explosion of one or more supernova, and that magnetic turbulence still exists today close to the heliopause. If so, the probe's instruments will likely be dark by the time they reach a different magnetic orientation due to their increased distance. The twin probe's cosmic travels have only begun, despite the historic Voyager mission likely coming to a conclusion. While Voyager 2 will pass 1.7 light-years from the star Ross 248, Voyager 1 is expected to wander near AC plus 793888, a star in the Camelopardalis constellation, in 40,000 years. Click on the subscribe button. If you are finding this video interesting, it will pass by Sirius 4.3 light-years away in 296,000 years. As they continue their lonesome journeys through the Milky Way, these tiny brave probes will probably outlive the Earth itself. Additionally, they will serve as a memorial to the brilliance and tenacity of civilization if they happen to come across intelligent life in one of the furthest regions of our galaxy. A golden audio-visual disc known as the Golden Record is located on each of the probes. They also contain greetings in 55 different languages, sounds of whales and babies crying, music by Mozart and Chuck Berry, and images of Earth and its diverse life forms. They would provide a far-off outsider with an insight into our identity and the character of earthly life. As for us, we must bid farewell to these cherished companions and move on with our own lives on Earth. We can only hope that the Voyager mission is just the start of our exploration of space. Amazingly, we haven't simply sent spacecraft into orbit. SpaceX has even sent a Tesla beyond Mars orbit. 2020 saw its closest approach to Mars, which was only 5 million kilometers away. If you want a high-end Tesla for yourself, it probably won't take you to Mars. So, now that the Voyager mission is nearing its final days, we might ask, what did Voyagers 1 and 2 find outside? How well suited were the probes and their equipment to the rigors of interstellar travel? Why then are NASA scientists taken aback by what they discovered? Want to know more about NASA's ending its iconic Voyager mission after 45 years? Watch this video popping on the screen right now to learn more.